Today we're going to look at this LeetCode question 104, maximum depth of binary search tree, as an introduction to recursion. Let's first have a look at what we need to do for this question. Essentially, we are trying to find the maximum depth of the binary tree, which is defined as the number of nodes along the longest path from the root down to the furthest leaf node. In another word, is basically like counting the maximum levels that from the root to the furthest leaf node can go. So in this question, we can solve this question with simple recursion. But before we go into the implementation, I just want to share some recursion notes. For a lot of beginners would be struggling to understand recursion, it is important to understand that every call to the recursive function itself with different input occupies different memory in the program, and then the program control return to the caller once in the call the recursive call is finished, and so on and so forth. And so to solve a recursive problem, it is also useful to remember the thinking pattern. That is asking yourself, what's your base condition, also known as when does your recursive function end? So it needs to have a base condition so that the program doesn't goes on recursively forever. And how do you build your solution recursively? That is, if you know the answer to an input, let's say n-1, can you find the answer for the input n? Or if you know the answer to the subtree, can you find the answer to the tree itself? So therefore, find the patterns that you can derive fn from fn-1, and then find your base condition, then you will have your recursive function. So that is the notes. So now we coming back to the question itself. So how can we define from the second thinking pattern, how can we derive a solution for this problem? So what would be our base condition? For binary tree, it is pretty common. The base condition would be when the tree does not exist. So if the tree does not exist, if the root does not exist, what would have been the depth? So it is intuitive. If the tree doesn't exist, our depth would have been 0. So if the tree exists, otherwise the tree exists. So how would we divide this problem further recursively? So now it is now we have for binary tree, we basically have two branches, the left subtree and the right subtree at any given point. So we're looking at the root. The root is not empty. Then if we call this function recursively root.left, so because this function is defined as getting the max depth from this current node, so this, when we are calling it with input root .left, that is essentially giving us the max depth from left subtree. I'm just making it very verbose for easier understanding. And similarly, if we call this function with the right pointer, then we would have got the max steps from the right subtree. Now with these two numbers at hand, that is we have the solution for our sub problem. We know the max steps from the left subtree, we know the max steps from the right subtree. How to determine what's the max steps for the current root, for the current tree starting from the root, which is very intuitive. If the left subtree has a length of 1 and the right subtree has the depth of 2, which means our starting from the root, we will take the max out of one of these. Then we'll plus 1. We will take the max and we will add 1. That will be the depth counting from the current root, and the recursive function taking care of returning to the ultimate root itself. That will be our answer. So essentially that is finding the pattern. This max of left and right and plus 1 is finding the pattern from a sub-problem solution to the current solution. And so this will be the solution for this one. And you can add a couple of test cases. For example, we can test with a tree that has no node. Can also test with a tree that has only one node. Alright, you get the gist of it. That is for this video. Thank you.